From ICID Central Office, New Delhi, we invite all the participants who have joined this webinar. And today's webinar topic is webinar on advanced micro-irrigation technology with precision water and salt management. And this webinar, the speaker is Professor Yao Kang from Chinese Academy of Sciences. And two panelists are there, Dr. Ivan W. Christian from Australian National University and Dr. Faisal Chenini, senior water expert from Tunisia. And this webinar session will be moderated by our Vice President Honorary Dr. Mohammad Wawa, who is Chairman of Working Group on Capacity Development, Training and Education and African Regional Working Group. So with this, as we all know that micro-irrigation has a number of advantages, like increasing beneficial use of available water, improving fertilizer and other chemical application, enhancing plant growth and yield. And there are a number of other benefits are there. So this webinar will help all of us to understand the advanced technology of micro-irrigation, their design, and then their benefits and other application, especially with for precision application of water and salt management. So just for information of the participants, that after the question answer session will be after the presentation in the end, and then all the participants who are interested in raising any question, they can send their questions through question box, and those questions we'll try to answer all the questions. And if time permits, then we may give chance to few attendees, a few participants to raise their question or give their experience or views. And then recording of this webinar will be available in a day or two on our website, because after processing, we'll upload it on the website. Because some of the participants are interested in knowing whether the recording will be available or not. So this will be available. And then the participants who wants to share their views, they can raise their hand, and then as per the time availability, we may give them chance. And now I'll request our President, Professor Dr. Raghav, to say his opening remarks. And then we will hand over to Dr. Wawa to moderate the session. So Professor Dr. Raghav, President ICID, now he'll give his opening remarks.
Okay, thank you. Just I have one slide to share.
Oh, please, sir. 1 minute. Stop share. Yeah, please, sir. Yeah.
Hello, good morning, all, and good afternoon, or I would say good day. I start by really thanking all of you, especially our distinguished speakers, Professor Yao Kang, Dr. Faisal Chini, and Dr. Ivan Christian for their willingness to share their experience and valuable knowledge with all of us. I would like also to thank Dr. Muhammad Wahba for his really excellent efforts for ICID and for the young professionals, especially the African Working Group as well. So I would like to thank you all for coming and organizing and participating in that webinar. I have only just one slide to highlight from my own experience the issues that I myself met during a long career. So let me now go to the next slide. And the issues that I met personally for that irrigation in particular is that we have new irrigation systems now, such as the micro and nano irrigations, and they are important in water energy and labor cost saving. At the same time, they produce higher yields and improve the water productivity and farmers' income. So they are really wonderful new technology And we will be, of course, all of us interested to know more from our distinguished speakers today. However, when using saline water and the treated wastewater, a careful management is needed, as what's the best system to use for such poor quality water, whether we use drip or sprinkler or center pivot, and also what sort of design suitable for us. Should we use special drippers to cope with the salinity issue or the bacterial issue of treated wastewater? Should we use low nozzles sprinklers to not to allow salt to fall on the canopies? Should we use a subsurface drip irrigation to minimize the evaporation and the salinity accumulation at the surface, and also to avoid wastewater getting in touch with the farmers? Shouldn't we use crop with salinity tolerant? And the land management also, like mulching and so on, this is decreases the evaporation and of course decreases the salinity accumulation. So when we are using the micro and nano irrigation, we take into consideration other factors to maximize the benefits, like this management I mentioned. However, there is another issue I met from my experience. Although the micro and nano irrigation save water, we can only achieve that by accurate and calculations or measuring the irrigation water requirements. Otherwise, the benefit of using such efficient irrigation system will not be achieved if we do not use methods or equations that give accurate estimation of crop water requirement. Because I found a lot of people, they use nano and micro irrigation, but they calculate the crop water requirements that with overestimation over the actual need. And for that reason, you might not get the benefit of using micro or nano irrigation if you are wasting water by miscalculation or exaggerating in the amount needed. Another issue also I met during my work is that when applying saline water, one needs to monitor in situ the soil moisture and salinity at the same time, and the location, both of them at the same time, the same depths, using sensors. And sensors nowadays are not expensive. And the reason for that, what I found, the laboratory measurements, especially salinity using saturated paste extracts and so on, do not accurately represent the field conditions. So these really some issues that I met, and I'm not really going to take much of your time because we have valuable knowledge now to have and to hear from our distinguished speakers. And once again, I thank our speakers, I thank the coordinator, and I let you to enjoy the day. Thank you very much.
Dr. Wawa, now we hand over to you so that you can moderate the session and introduce the speaker panelist. Dr. Wawa.
Yes, thank you very much, Dr. Varma. Good morning, everybody from Egypt, and a good day wherever you are. I would like to welcome you all and the distinguished speakers, Dr. Yahu Kang, Dr. Ibn Kristin, and Dr. Faisal Shemini. In continuation to our webinar series, today the webinar will be about advanced micro-irrigation technology with precision, water and salt management. It's a pleasure and honor to have you all with us today, and I wish to have a very successful and valuable discussion. Allow me first to thank the ICID President and the main office for the great support for the activities of capacity building, development, training, and education for all young and non-young professionals. No doubt, these days in many areas of the world, there are a big worry about existing situation of water resources and its future under the climate change, and mainly under extreme events, and how water could be utilized with the maximum efficient ways and how to produce more with less. We are, as ICID and its working groups, are doing all the best to reach to the recent advanced technologies in water saving, best practice in irrigation and drainage agricultural water management and how to have more crops per less of water, energy, and cost. It's my honor and pleasure to be with you today as moderator for this important webinar. We are very pleased to have with us today 3 international experts. Professor Yahoo Kang from Chinese Academy of Science as a keynote speaker. And we have 2 international experts as panelists, Dr. Evan Christian from Australia and Dr. Faisal Shimini from FAO, Tunisia. In the webinar, we'll have 40-minute keynote for Professor Kang. Then we have 7 minutes for each of the 2 distinguished panelists. And then we have 30 minutes for open discussion. As Engineer Varma mentioned, you can send questions during the presentation, and we'll try to answer all after the presentation. And if we couldn't during the time of the webinar, we will collect all the questions and share it with you later on after the webinar. I would like to invite Dr. Yahoo Kang for his keynote presentation. And for your kind information, Professor Yahoo Kang obtained his PhD in 1997 from the United Graduate School of Agricultural Science, University, Japan. He is a professor in the Institute of Geographic Science and Natural Resources Research, Chinese Academy of Science. He is a distinguished chair professor of the Chinese Academy of Science, professor at the University of Chinese Academy of Science, vice chairman, Micro-irrigation branch, China Association of Irrigation Area, and very director, key laboratory of water cycle and related land surface process, associated editor, resources science. Professor Kang has a long history of research in the fields of water cycle in soil, plant, atmosphere, continuum, micro-irrigation and sprinkler irrigation, saline water irrigation, saline alkali, soil utilization for agriculture, including vegetation construction, hydraulic analysis and design of micro-irrigation system, equipment development of micro-irrigation system. Professor Kang has made internationally known achievements in both theoretical and technological aspect of micro-irrigation and sprinkler irrigation, drip irrigation with saline water and saline soil utilization for agriculture. He published more than 270 papers, obtained about 30 national patents, 9 software copyrights, and was one of the main members setting 2 national standards and 2 national professional standards. Professor Kang is going to reduce the advanced micro-irrigation technology with precision water and salt management based on his research result. Please, Professor Kang, the floor is yours, and please share your presentation.
Okay, thank you. Now I'm going to start my presentation now. Okay, good morning. And in China, now it's afternoon. So I also say good afternoon, everybody. I'm very glad to have a chance to and share our research results here. Also, and exchange our opinion each other. My presentation topic is advanced micro-irrigation technology with precision water and salt management. And in the past 20 In this is the research field, my research team. First is the water cycle in soil plant atmospheric continuum. Second is micro-irrigation and sprinkler irrigation. Third is drip irrigation with saline water. And fourth, agriculture and vegetation construction in field with saline arid soil. Also, we use a micro-irrigation method. And we also developed the methods for hydraulic analysis and the design of micro-irrigation systems, and develop some material or some micro-irrigation systems. And in the past 20 years, and for the purpose of our research work, we have established over the 20 experiment stations in China. Now this yellow one is under operating, and the white one is for demonstration, and the blue one now is closed because our research work have already finished over there. So as the contents of my presentation include first introduction, second water management, third management, and finally I will introduce several micro-irrigation systems for different type of users. So firstly, and what is micro-irrigation? So micro-irrigation, and as we know, is including drip irrigation, micro-sprinkler irrigation, and bubble irrigation. So the definition of the micro-irrigation is as follows, and that is micro-irrigation is the slow application of water on, above, or beneath the soil. The features of micro-irrigation are, first, water is applied at a low rate. Second, water is applied over a long period of time. Third, water is applied at frequent intervals. And fourth is water is applied near or into the plant root zones. And the final is water is applied by low pressure delivery system. So this figure shows the soil moisture status under the surface irrigation, sprinkler irrigation, and micro irrigation. This yellow one is for the surface irrigation. The green one is for the sprinkler irrigation, and the white one for the micro irrigation. We can see, and when we use micro irrigation, we can capture the soil moisture condition very well according to the crop characteristics. So the advantage of micro irrigation including, first, increase the beneficial use of available water. Second, improve fertilizer and other chemical application. Third, enhance plant growth and yield. And fourth, limited weight growth, decrease the energy requirements, improve the practice, and reduce the salinity hazard to plants. So the major issues for micro-irrigation, as said by the President Lagabi before. And first is when to irrigation. Second, how much water to apply. Third, how to make the technology more simple and easy for operation. And what irrigation systems are more convenient operation, but more precision in application of water and fertilizer for our farmers. So the others is, in arid and semi-arid regions, source in irrigation water enters the soil with irrigation. So leaching water must be considered during irrigation to prevent soil accumulation in the soil. So this map shows that after drip irrigation, if we don't have the good method for fertilization, so there is some, soil, this black one region is accumulated in these regions. So if year by year, so this finally, so it's a new salinization problems will be occur in the agriculture field. So, for the fertilization, and the method suggested in the irrigation handbook of the United States, that is this equation. That is the irrigation amount equal to the ET divided by the 1 minus ratio of the additional irrigation water for fertilization. So how to determine the ratio of the additional irrigation water for fertilization? So there is an equation suggested that is LI equal to the ECAW divided by the ECD. ECAW is the EC of the applied water. ECD is the EC of the drainage water, can be set as a threshold of the crop soil tolerance. But as we know, to get the correct ET is quite difficult. So the problem is how to get correct ET. If the ET is not correct or has much errors, so the irrigation amount will be not correct. So it's another, and so it's and we said, and to get correct ET is quite difficult. So whether there is a more easy method for irrigation scheduling for both purpose of irrigation and fertilization. So, and firstly, for the water management, and in the past, in 2001 and 2002, we selected potato and radish as experiment materials to study the water cycle process at the draw of the crop water consumption in drip irrigated field in order to develop a simple but accurate irrigation scheduled method for Chinese farmers. So first I will introduce the effect of the irrigation frequency on crop growth and water use. And why we choose the potato and radish? Because the potato plants are very sensitive to moisture stress because their root distribution are shallow. And about 85% of the root is concentrated in the upper 30 centimeters of the soil. Water stress will cause significant yield cuts, but excess water may cause too many stems and leaves and affect tuber yield and quality. Radish is the one of the most important vegetable in the second half of the year. It is one of the relatively drought-tolerant crops. So, and we set, the very, it's a very nice irrigation system instruments. And we have, for each treatment, we have the separated and drip irrigation systems. We use the gravity drip irrigation system. So this is the control unit for drip irrigation experiment plant. So for the purpose to get the correct ET, and we developed the Hagen electronic weighing lysimeter. This is a system for weighing. And we also sent the tensimeter, one set, one treatment, one set. So why we use the tensor meter? And the design one set of the the mercury tensor meter with 30 probes for each treatment, because we want to observation the soil matrix potential distribution at the drip irrigation emitter. So why use the tensor meter? Because soil water potential is not affected by the soil texture, because it describes the continuum of energy status of the water in the soils. On the other hand, as we know, and in nature, water flows from a point with a high soil water potential to a point with a low soil water potential. So we thought that soil salt leaching can be controlled where? By controlling soil matrix potential. So, and firstly, we designed 6 treatments for drip irrigation frequency of potato. That is once every day, once every 2 days, once every 3 days, once every 4 days, and once every 6 days, and once every 8 days. And for potato and radish. So the total amount of irrigation water for the different treatments was equal. So the irrigation amount per term for frequency of once every day was equal to the evapotranspiration of the previous days as measured using the electronic weighing lattimeter. So irrigation amounts for once every 2 days, 3 days, 4 days, 6 days, 8 days were the accumulative values of the once every day. So that makes the total irrigation amount as the same. So the plant height, leaf area, stem diameter, root distribution, yard, and the soil nutrient distribution were measured during the potato growth. You see, this is each point that is for the purpose of measurement, the soil matrix potential. Also, we take the soil samples at this point. So, to do the experiment of the drip irrigation is quite and hard work, because we should take many the soil samples for analysis. So finally, we found, for the potatoes, the yield is decreasing as the irrigation frequency is decreasing from once every day to once every 8 days. And the yield is the highest when the irrigation frequency is once every day. But for the radish, you see, and the yield is increases with the irrigation frequency decreases, and each 5 days, once each 5 days apart, the yield is the highest. They turn to the turn to decrease. So evaporation is for both potato and radish, and it decreases with irrigation frequency decreases. So the water usage efficiency and is for the potato is decreasing. It decrease with the irrigation frequency decrease. But for the radish, you say it is firstly it's increasing, and when it is for the once each 6 days, it's the highest yield water use efficiency, and then turn to the decrease. So during this experiment, we had a very important fund that the soil matrix potential condition in main root distribution layer can be maintained when we control the soil matrix potential at 20 centimeter depth immediately under drip meter. So this, as we know, tensor meter have already found for the very long times. And also scientists said tensor meter would be good for the irrigation scheduling. But at that time, and people don't know. And what depth is the best? How many sets of the tensor meter should be set in the field to measurement the soil matrix potential? But we found only at 20 centimeter depth immediately under drip meter is okay. So based on this finding, and we quickly designed the 5 treatment of soil matrix potential at 20 centimeter depth for potato and radish. And that is the 5 treatment is minus 50 kilobar, minus 25, minus 35, minus 45, minus 55. So irrigation was applied only when the soil matrix potential reached the targeted value for each treatment. Also, you see, we have the variance meter and everything. So, and we found that, you see, when we control the soil matrix potential at 20 centimeter depth, we can control the soil matrix potential in root distribution zones where this is before irrigation and after irrigation. And we found, when the soil matrix potential is higher and the root system is smaller, and as the soil matrix potential is decreases, the root system gradually increase. You see, and when it is at treatment F5, that is 50 minus 55, the root system is the largest. Also, that this is a yield. Yield is increases with soil matrix potential, decreases from minus 15 kilopar. And when it is reached to the minus 25 kilopars, the potato yield is the highest, and then turn to the decrease. And for the radish, and it is, the yield is, at the soil matrix potential is about minus 35 kilopar is the highest. So this is evapotranspiration for both potato and radish are similar, that is decreases with the soil matrix potential as decreases. So it is very interesting that you say the water use efficiency, and this curve is very interesting. So yesterday, Dr. Waba and we talk, we discussed this curve. You see, under the yield is increase with soil matrix potential as increases when it is at the 28 minus 28 kilopars turn to decrease, and then about minus 45 kilopars it turn to increase. So for the radish, it have the similar, the similar and the rules, but the potato is more shapely, the curve. So why there is this phenomenon? As we, this is because there is a this is because you know, the after when this is a change in WE up and down with the increase of the soil moisture potential in this range for potato should be that at this stage that the yield of a potato begins to be affected. The decrease of the yield was larger than that the transpiration. After soil moisture potential from this range, the degree of the water stress of the potato increased more, and the potato began to self-regulation, and making stomatal opening smaller. Transpiration intensity increased, but that the degree of the yield was less than that of the transpiration. Therefore, WE turned to increase again at this point. So, and in the past 20 years, we have already carried out experiment for over 20 varieties or species of row crops. And the soil moisture potential thresholds were determined. And for vacuum, oil sunflower, cotton, tomato, bean, bitter melon, squash, lettuce, radish, and cabbage, it's minus 35 kilopar. And for the potato, cucumber is minus 25 kilopar. And for the celery is minus 20 kilopar. Now then we developed a very simple method. We just, find 3 representative points in field. Each point set 1 centimeter and 20 centimeter depth immediately under drip emitter. And the irrigation amount for each irrigation event is the same. Or we can divide it the whole crop across season as 2 to 3 stages and make the irrigation amount for each stage is the same. So the irrigation amount usually can be 5 to 10 millimeter. Of course, that should be determined according to the lateral spacing and the soil characteristics. When the soil moisture potential observed by the tensiometer is below below the scheduled range, and start irrigation. After irrigation, check soil moisture potential observed by the tensiometer again. If they are lower than the minus 15 kilopar, 1 more irrigation should be applied. Now you can see, and the irrigation scheduling now is very simple. Irrigation quantity for each event is the same, and the irrigation time is determined by tensiometer. For the farmer easy to use. You say we make different colors, and they can easy to find the range of the suitable soil moisture potential. So this is for the annual crops. For the perennial crops or trees, we suggested to set 2 centimeters, one at 20 centimeter depth, another at the 50 centimeter depth. Also, irrigation amount for each irrigation event can be the same. And when the soil moisture potential of 20 centimeter depth at this centimeter is lower than that is the threshold start irrigation. After to check the tensiometer of the 50 centimeter, this depth, if they are lower than the minus 50 kilopar, when more irrigation should be applied. This is also very simple, very easy. So now I'm introducing the third management. First, I would like to introduce the methodology. That is our thinking. So as we said, in arid and semi-arid region, source in irrigation water enters the soil with irrigation. Leaching water must be considered during irrigation to prevent soil accumulation in the soil. So salts exert both general and specific effects on plants, which directly influence the crop yield. Additionally, salts affect certain soil physical chemical properties, which may affect the suitability of the soil as a medium for plant growth. So this is the system of the water cycle in the plant and the soil and the atmosphere continuum. So the precipitation and the water, irrigation water applied to the soil, part of the water storage in the soil for plant transpiration, growth, and evaporation. And that is usually we set as a field capacity, the maximum, the soil moisture content. And another part that is the water is more than the soil field capacity. That part of the water is the deep population, and from the soil and gradually and flows to the groundwater. So this part of the water is important. Is why it is important. For the third leaching is important. But if we control not good the deep population, if water too much water, so that means water is wasted. Too small water, the third may not be leached. So that means how to make the system can create the correct deep population is important. So this is and as we said, and the water flows in the soil is dependent the soil dependent the total soil water potential, but the total soil water potential are determined by the soil water content, that is soil matrix potential. So and we think because we found when we control the soil matrix potential at 20 centimeter depth immediately under the drip emitter, there is good relations with crop growth and with and we developed the simple and irrigation schedule to the method. So we think whether we can control the soil matrix potential at this point, that can create the correct exactly the population, deep population for certain leaching. And so we had the 5 experiment for 5 treatment in Kalamai, this area. And the 5 treatment of soil matrix potential and 20 centimeter depth we designed for the cartoon. That is minus 10 kilopar, 20 kilopar, 30 kilopar, 40 kilopar, and 50 kilopar. Irrigation was applied only when the soil matrix potential reached this target values for each treatment. So this is our experiment field. So this we found the relationship between the deep population at the soil material potential and the 20 centimeter immediately under drip emitter. You see, there is a very nice, very good and relationship. And this is the deep population. As the soil material potential decreasing from minus 10 kilopar to the minus 50 kilopar, you see that the deep population is gradually decrease. So there is a very good relation, you see. So and we found when the soil material potential at 20 centimeter depth is minus 20 kilopar. So there is salt can be leaching where. So this is soil salt content. We measure it as ECE, and that is you see, and this is the beginning, the red line, and this line is minus 20 kilopar. You see, and at the beginning and the after harvesting, there is no salt accumulation in the soil. So, and this is the relationship between the evaporation and the soil material potential. This is for the cartoon is similar to the potato and radish, and I now mention it is now introduced here. So we found that also, for the cartoons, when soil material potential at 20 centimeter is contracted, it's the minus, and the threshold is the minus 20 kilopar. The yield, the highest for both years. And we also found, and for the Wolfberry orchard, and when the soil material potential at 20 centimeter depth contracted as a minus 20 kilopars, there is no salt accumulation in soil and the salt leached where. This line shows, the beginning and after harvesting, and the winds range from 0 to 50 centimeter from lateral in the horizontal direction after 3 years. And this is the ECE, and a distribution within the 70 to 150 centimeter from lateral in horizontal direction after the 3 years. Because the spacing of the Wolfberry, raw spacing of the Wolfberry orchard is 3 meters. 3 meters wide the spacing. You see, this is the beginning. This is after. You see, there is no salt is leaching where. So also results indicated that the salinity in whole soil can be leached. For the cartoon, that is usually the water leaching, that is the deep population is about less than the 20 millimeter. For the Wolfberry, it's less than the 35 millimeter. That means there is when we can try the soil material potential at this point, and according to the soil material potential minus 20 kilopar, we use a very small amount of water, and we can leach the salt where. Yeah, this is the Wolfberry yield. Also, minus 20 kilopars is the highest. So, and based on this study, so we developed the irrigation scheduling method for salt management. That is also, we find 3 representative points in field, and each point we set a tensor meter at 20 centimeter depth immediately under drip emitter. So irrigation amount are the same. Only we can transfer your material potential is minus 20 kilopascal. Yeah, this point is different with the previous. Also, for the for the perennial crops or trees, yeah, it's similar. And when we control soil material potential, and the 20 centimeter depth is minus 20 kilopascal, so it can be reached there. And the yield is also very high. So this the above results we also verified in the Wulan experiment and the demonstration in Qinghai province here. The experiment, and we found, you see, when we control the soil material potential and 20 centimeter depth as a minus 20 kilopascal, and this is for irrigation scheduling. So it's a yield of the potato, and under this condition is almost, you see, 2 times of that under flood irrigation condition. And so irrigation amount is half than the flood irrigation, and the irrigation water use efficiency is almost 3.5 than the flood irrigation. And this curve you see about the certain distribution in the soil, and it shows there is no certain accumulation in the soil. So that means our method is we verified it in another place also is this correct. So now I'm going to introduce several drip irrigation systems for different type of users. First, I would like to introduce the irrigation situation in China. China's farmland area is about 128 million hectares. And the effective irrigated farmland area is about 69.1 million hectares, accounting for 54% of the total farmland area. Over 75% of the country's total grain production, over 90% of the total cotton and the total vegetables productions are from about 54% of the total irrigated farmland in China. So the areas irrigated by micro-irrigation accounts for about 9.6% of the irrigated cultivated land. So that is, we can say the area is the largest in the world now. Largest in the world now. So as we know, and China and our farmers and for each farmers, and their land is smaller. Also nowadays, and we have some of the, to make them make as the group and the management, and also some the large the managers and to together and for the agricultural practice. So so under this situation, and we developed 3 models for different type of farmers. One is a family by family irrigation model. This means in micro-irrigation systems, there are many farmer families. Second is a group by group irrigation model. This is for the one irrigation system, one micro-irrigation system. There are many farmer family, but they can group as several groups. And the third is as the farm as the a large farm. a large farm. And for this situation, and we call that as unified irrigation by the specified operator. So for each model, we developed the irrigation systems. For example, this is we call the remote controlling drip irrigation system using ICID prepared and interlocated controller. And each farmer, there is one controller, and also the fertigation system. And this is the hand control and the tensor meter, and the layout of the system, and the farmers found that when they use our irrigation, micro-irrigation systems and technologies, they found that they can save irrigation water by about the 65%, increases production of the grape about 50%, and saves electricity by the 70 yuan per mu, Chinese mu. That is about $150 per hectare, and saves labor cost by the $165 per hectare. So fertilizer about the $115 per hectare, and saves total production cost by about $445 per hectare. This means also when you use the macro irrigation, and accepting the increase the yield, and they can get the much beneficial, and they can reduce the production cost. Also, this is for the group by group models has a similar results and in the beneficial. Also, this is for the unified irrigation by specialized operator models. Also, you see, they can increase the yield much, save the labor cost, save the electronic cost, and everything. Also, this is this system you see now is very simple. This is remote controlling and monitoring drip irrigation system. So the farmers and they read the tensor meter and push the button, send the signal, and the system automatically operation and start irrigation. Of course, nowadays this is about 15 years ago's production. Nowadays, so we can use the ourselves. So it's more convenient. So it's in the past 20 years we developed different systems for our different models. And there is a computer controlling full automatic micro irrigation system, full automatic micro irrigation system without computer, and the automatic micro irrigation system with timing controller, and standard the manual controlling micro irrigation system. So that is for different type of farmers. Okay. Okay, that's all. Thank you very much.
Thank you very much, Professor Kang, for the comprehensive presentation. I think based on your long experience, it is clear now, based on this research, we learned more how we can control the soil metric potential, at what the effective depths, and at what value we can monitor, how we can schedule our irrigation within micro irrigation system. Also, how we can manage salt with micro irrigation. I am very glad also at the end you showed us how the different model for application started from small farmers, group of farmers, group to group, and also for larger scale application. And in fact, we are looking forward to fill the gaps between the science the advanced science and applied science, how we can take this output, how to take this advanced technology to introduce in a simple way to the farmers. And in this regard, we are very glad to have with us today two international experts to follow up your presentation, Dr. Kang. And I would like to introduce the two panelists with us today, Dr. Evan Kristen. Dr. Evan, born in Kenya.
Professor Kang, can you stop sharing your screen?
Okay.
Yes, Dr. Evan Kristen, born in Kenya, brought up in Zambia and educated in England as an agricultural engineer. He arrived to Australia to do his PhD with CSIRO. Then for his PhD, he reached the cost-effective method for managing water logging and salinity in irrigated agriculture. He remained 17 years with CSIRO, searching natural resources management, of which about 15 years were as a project leader and about 10 years as a team leader. During his time, he was a principal investigator, project leader on about 16 projects. Dr. Kristen has researched irrigation management, water logging, salinity control, design and the management of evaporation basin, the use of irrigation drainage, sewage and winery wastewaters for irrigation, regional management of irrigation and the drainage water, remote sensing. And in fact, he has a long experience, long research experience in many countries, including Pakistan, China, Colombia, Iraq, Egypt, California, and South Korea. Dr. Kristen, nowadays, he already established a consultancy company, Benefit Service, currently working with the Australian National University on irrigation related research in Africa and the Australian Center for International Agricultural Research on Program Management. Also, it is my pleasure to introduce the second international expert, Dr. Faisal Shinini. Dr. Faisal Shinini, he is a Tunisian citizen. He is a senior water expert with an experience of 25 years at the international level in Africa and the Near East region, particularly in the following sectors: integrated water resources and irrigation management, water policy development, water governance, non-conventional water resources, technical assistance and supervision of the country's projects, programs, strategy and policies related to water resources management, capacity development. He has significant experience with FAO, around 15 years, as an international consultant, advisor, and senior technical assistant, project coordinator, project manager in the field of water resource management, water policy, water governance, irrigation and non-conventional water reuse, climate change, and capacity development in the Near East and the North Africa region. Welcome, Dr. Evan and Dr. Kristen, and allow me to start with Dr. Evan Kristen. As we hear from Professor Kang, now we have a long term of research result and regarding the advanced technology in micro-irrigation and how we can manage salt with micro-irrigation. Dr. Evan, based on your long experience, could you please tell us how we need to fill the gaps between science and applied science, how to translate the outputs to farmers in a simple ways or language? Is it also, it could be sustainable for a smallholder farmers? And is there a need for agricultural drainage with micro-irrigation? Please, Dr. Ed, the floor is yours.
Thank you, Dr. Waba, for that those questions, and thank you, Dr. Kang, for the very thought-provoking presentation and very thorough presentation. I think there's a number of elements here that we could talk about, and I think one of the important ones is also fertigation. So one of the key aspects of switching to micro-irrigation is that the farmer also has to understand and undertake fertilizer application through the irrigation system, which is quite different to normal farming practices where they apply the fertilizer to the soil directly. So when we look at soil moisture tension and wetting zones and amounts of water applied, we also need to consider the NPK that's being applied at the same time, and there's a very strong interaction between those. One of the key motivators for many farmers is to minimize fertilizer use, because fertilizer is very expensive and getting more expensive every day, as we know around the world right now. It's getting prohibitively expensive. So actions that can get the most result from fertilizer use is really important. And I think that's another strength of micro-irrigation, and in this particular time in the world with the expense of nitrogen. And so maintaining the wetted zone and the root zone and maintaining the fertilizer status is very important. So I'll just flag that element as well. And then in terms of the complication of salinity management, I think with salinity management, clearly it depends upon the salinity of the applied water, the soil type, and the rainfall amount and regime. So I'll just give you a little experience, like from some of my experience, for instance, under heavy clay soils with drip irrigation on permanent tree crops, and about 300 millimeters of rain per year, falling in relatively larger amounts. Our analysis across a number of farms that had been using drip irrigation between 8 to 12 years, that that amount of rainfall, 300 to 400 millimeters, and the amount of water applied would have been 1,000 to 800 to 1,000 millimeters by the irrigation. In that particular situation, we found that the rainfall itself was controlling the salinity in the root zone, and so therefore there was no, and the water quality was good also, so there was no actual need to apply any leaching fraction with the water. Of course, that really depends on the circumstances, and so that that would need to be analyzed for the different soil types, different water qualities, different cropping regimes, and so on. So it's just a point there that rainfall is actually very important in micro-irrigation. Even though we're talking about controlling the water through the micro-irrigation system, we still do get rainfall, and taking advantage of those rainfall events, either to supply water. So that, again, tracking the soil moisture tension is important, or as a leaching event is very useful. Now, getting to your other questions, Dr. Warber, obviously there's a big gap between experimental application of micro-irrigation and micro-irrigation out in the field, and the capacity of farmers to manage and monitor large-scale drip irrigation or micro-irrigation. And often those efficiencies gained in research kind of environments, we don't achieve them out in the real world, but that doesn't mean that there's not significant benefits. What it means is that it's a learning curve for farmers, and the tools used to monitor are really important. And we're still struggling to find good tools to monitor soil moisture. Dr. Kang's work out in the field was mostly using tensiometers. And we know the difficulties of using tensiometers, maintaining tensiometers, and so on. But luckily there are some new tools being developed, like the chameleon sensor coming out of Australia, that also provides that same soil moisture potential, but provides it as a color. So you get a kind of traffic light indication, and it's the work of Dr. Kang is exactly right, that the optimum soil water potentials are generally around 20 kPa, and not wanting it to get too wet, not wanting it probably less than 10 kPa, and not wanting it more than 50 kPa. So that 20 to 50 is, Professor Kang's work has shown that very clearly again, that's very suitable. So the kind of tools we have developing, providing that in a color scheme, which is much easier for farmers to interpret and can be logged over time as well. So I think it's really important with micro-irrigation to think hard about how the soil moisture will be monitored. Obviously digging, feeling the soil with your hands and so on is also very, very useful, and allows you to monitor more areas than, say, if you've only got 3 locations with a tensiometer. You need to back that up by checking other areas manually with a spade. Your last question was around drainage, I think, Dr. Wobber, and just very quickly, I think that the need for subsurface drainage probably depends on the depth to the water table currently. So if you have a deeper water table, it obviously means that you get less upflow of moisture from the water table, and therefore less transmission of salts up from the water table into the root zone. So deeper water tables is probably unlikely to need any subsurface drainage with drip irrigation. But also we have some experience in Australia where you may switch from flood irrigation to controlled irrigation, and the water table may be very high because of the previous flooding irrigation, the previous furrow irrigation. But then with the switch, over the following maybe 18 months to 3 years, the water table declines because there's less water being applied, and that the water table gets deeper, and you get a new equilibrium with a deeper water table, and then that also provides ample opportunity for leaching, so drainage is not required. So I would recommend, if switching to controlled irrigation in shallow water table environments, that maybe do an experimental area and see how the water table changes with drip irrigation initially, to decide whether or not subsurface drainage would be needed in the longer term. So those are my comments. Thank you very much.
Thank you very much, Dr. Ibn. And I think you raised a very important point about the quality of irrigation water is very important, especially with the consideration for the salt management. And also the existing amount of rain is very important. And it will be nice for Professor Kang, because he didn't mention how much rain already in the area mentioned in his research, because it will help a lot for leaching. And I think with the drainage point of view. For longer term, it needs more discussion about, because at any condition we need to have a good monitoring to see what is the situation after we move from flood irrigation to micro irrigation. We have to monitor the salinity, we have to monitor the shallow groundwater level, and also based on our experience, maybe we could face some change in the soil probability, which we could have different in hydraulic conductivity, which in the future, longer term, we might face some problem. So it needs a good monitoring. And I think now we can move to the second international expert, Dr. Faisal Shimini. Please, Dr. Faisal, based on your long experience, could you please tell us more about the development of micro-irrigation in the world and mainly in the arid region? And also, what is the paradigm, micro-irrigation technology and the water scarcity? And also, for our condition as arid and semi-arid region with water shortage, how much reduction with the implementation of such deficit irrigation strategy could be acceptable by the farmers? Please, Dr. Faisal.
Okay, thank you very much, Dr. Mohammed. Hello, everyone. First of all, I would like to thank Professor and Dr. Ragab, the ICID president, and all colleagues from ICID for the organization of this very important webinar. And I would like to thank all the participants. I think we have more than 300 participants, and this is a good indicator how is important this subject of the webinar. Dr. Khan explained, gave a simple and very important definition of micro-irrigation. As you know, micro-irrigation as a technology has matured into a reliable water and fertigation management system, mainly for crop production over the past decades. And the use of this technology continues to increase rapidly during these years. And during the 80s, micro-irrigation started penetrating in developing countries, mainly in India. And a few years later, in USA and in China also. And after that, in the Near East and North African country, where water scarcity is a huge problem in these countries. If we would talk about the statistics in 1980, the total irrigated area by micro-irrigation system was around 0.4 million hectares. And now maybe or around 2020, the total of irrigated area is around 15 million hectares, which is around 6% of the total area irrigated in the world. These statistics maybe could be discussed because sometimes there is a confusion between micro-irrigation and drip irrigation. So this is, we can keep this statistic very carefully. This is about the development of micro-irrigation. Dr. Mohammed, you asked a very important question. It's maybe we can start discussing that, how we can take it as a paradigm, the micro-irrigation technologies and water scarcity. You know, the most appropriate micro-irrigation technologies to use will vary from place to place. And depending on a wide range of circumstances. For example, climate and water scarcity, and that's why we link usually micro-irrigation technology and water scarcity, and also traditional agricultural background of local people, for example. So there is, as I said, there is a link between water scarcity and micro-irrigation. In addition to that, micro-irrigation technologies do have important benefits, as Dr. Khan detailed. For example, they save labor, fertilizer, and chemical can be precisely and economically applied, as you know. Also, it was mentioned the leaching of mainly nitrates and other pollutants. But the most commonly assumed benefit is the large quantities of water that are saved. And this is the most important thing. That's why we link usually micro-irrigation and water scarcity. We can link them. We can talk about paradigm. And you know, the micro-irrigation could be a solution mainly in countries they are affected by water scarcity, and this could be a solution to cope with water scarcity that is posing serious threats to population, rural livelihoods, and mainly threats for food security. I think that's why we can talk about this paradigm, but we can discuss, we can open the discussion for that. I think you asked it for, yeah, this is very important. You know, when you are in semi-arid or arid region with water shortage, you know, when we use the strategy with deficit irrigation, the main objective is to increase the water use efficiency. And we will eliminate the quantity of water or irrigation that have a very little impact on yield. So the resulting yield reduction is very, very small. That's why we can adopt this strategic deficit irrigation to save water. We will have a few, very, very few yield reduction that will not, but if we compare it with the benefits gained through diverting the saved water to irrigate other crops, for example, and we will have more benefits. But the most important thing, we should have usually a deficit irrigation management. We should have an optimal or very important deficit irrigation management, and also as mentioned by Dr. Khan, the irrigation scheduling, which is very important. So irrigation management plus irrigation scheduling, these are very important to improve, to increase the water use efficiency, which could be done with micro irrigation easier. Over to you, Dr. Mohammed.
Thank you, Dr. Faisal, and I fully agree with you on the water scarcity. We need to have the best management, and I see also micro-irrigation is very important to cope with water scarcity. And under any situation, the monitoring and evaluation and good management is the most important key how we can face this kind of challenges. I think now it is the time for questions and answer, and maybe I can ask Dr. Varma to help us with the question received.
Yeah, Dr. Wawa, President Honorary Felix Renders is also available, and he has been upgraded in the panelist list. So
Okay, welcome.
He's also
Welcome,
an expert in micro-irrigation, so we may also hear
Yes.
from him. Dr. Felix.
Yes, most welcome, Honorary President Dr. Felix. You are most welcome. Please.
Well, thank you very much, Vice President Honorary Waba. Excellent presentation by Dr. Kang. Hello, Dr. Kang. It was really a pleasure listening to you in terms of this in-depth research that you did. Micro-irrigation, and then specifically drip and the use of that. Two things. The one is, and I know President Ragap would also like to comment on that. But you use the term water use efficiency, where you are expressing that in terms of kilograms per millimeter. Now, according to the international understanding of water use efficiency, that is not kilograms per meter. What you are referring to is water productivity. Water productivity is, of course, then where you are expressing the yield produced per unit supplied. So I just wanted to highlight that because water use efficiency, according to the international way of expressing that, that is where we are talking about the efficiency of any process, that is input-output. Both will have the same units. So in agriculture, the percentage of water the plant that is effectively taken by that plant. That is water use efficiency. So if the plant apply 10 millimeter and the plant only use 8 millimeter, then that will bring us to 80%. I just wanted to bring that. I know talk about water use efficiency in terms of kilograms per cubic meter in that sense, but I think especially while we're having at least more than 300 participants listening, that we just make sure about the units or how we are using that. That is just a comment on the side. Then the other thing is, I think very important. You talked about management, you talked about scheduling. Dr. Evan Christen also chameleon that was developed by Dr. Richard Sturzaker, and it is been produced here in South Africa. Impact that it make in terms of monitoring water potential on a quite easy methodology. Important, there are many other instruments that can be used and would sort of say it is important with all irrigation methods that we utilize different techniques to monitor and to manage application. With that, of course, is also the of the system. And we know that the drip system, as it's been produced by manufacturers, do comply to international standards. And one of the criteria is, of course, the coefficient of variation. The manufacturing of that products. And it must comply to certain CV values. But when it comes to usage in field, very important also, how are we using and monitoring? because the uniformity of application and distribution of water in drip irrigation systems are influenced by design, the topography, the operating pressure, the pipe sizing, spacing, and so on. But we also to measure what is happening in the field. Are ways and procedures where one can evaluate in a block, say 25 drippers, to find out whether it's to the uniformity. And then we use, of course, variation formulas to and there's of course the where we use a bucket, a stopwatch, and a measuring cup, and we get the value. And then we put those 25 values in a formula and we calculate it. But just for the interest also, we have developed here right in South Africa a uniquely innovative measuring
Felix,
cup.
you can switch off your video. You can switch off your video because sometimes.
Okay, well that
yeah, bandwidth problem may be there.
Is that better? Yeah, and up with this, where we have developed an innovative CV measuring cup. It works electronically, so you go out in the field and instantaneous, you can then determine what is the variation of irrigation system, and it will provide you with the liters per hour per dripper, as well as the average for, and as well as the CV. And if you take out the SD card, your computer, it will also give you the emission uniformity as other parameters that is important, because that is a measuring and of managing our water, just as a contribution. So thank you very much, Dr. Wawa.
Thank you very much, Dr. Felix, for your valuable comments. And in fact, regarding the water efficiency and water productivity, I think we have a discussion before between Dr. Ragab and Dr. Khan. And we agree with you, we have to follow the international standard for water use efficiency. And I think I can give the floor for Dr. Ragab. Maybe he has to add something. Can add something.
Thank you, Dr. Wahab. I really have nothing to add to President Honorary Felix. I think he explained it very well. The ICID stands on water use efficiency and water productivity. I agree fully with what Dr. Felix mentioned. So it's just a matter of terminology, really. Water productivity, to my mind, is, if not even more important than water use efficiency. So water productivity is really, for us, in terms of food security, is much, much important than water use efficiency nowadays. So I agree with the terminology that we should use water use efficiency when the input and output have the same units. Usually water use efficiency is dimensionless, has no units. But I have other actually comments on the excellent presentation of Professor Kang. Always he is very rich in the knowledge and experience, and we all learn from him. My experience in arid region might be different from the experience in China. In arid regions, tensiometers, they fall beyond the maximum range in most of the time. And I tried that myself in Egypt, and I found that different from the tensiometers when I used them in the UK, because it's a humid, more rainy area. So tensiometers, they still work within the range. But when you take these tensiometers to arid regions like Egypt and so on, that the 0.8 bar maximum range, which is about 80 kilopascal, that really with less frequent irrigation, you can easily reach and you go beyond that, and tensiometers don't work. So the tensiometers really can work in arid regions only if we have very frequent irrigation, that we wet the soil, that to make the metric potential not to fall beyond tensiometers range, although in the UK now, for chalk soils, we have now tensiometers, they can go beyond that classical tensiometers. So they call it theta probes produced by Delta T company in Cambridge. So there are tensiometers that go beyond that range for those who are interested, because classical tensiometers, we couldn't get them to work for chalk soils in the UK. So that's one issue with the tensiometers, especially in arid regions. The other thing is the leaching of salt. And the calculations, according to the old guide, says that the electric conductivity of irrigation water divided by electric conductivity or salinity of drainage water. When we use drip irrigation or micro-irrigation, these are efficient irrigation systems. Do not, and we do not expect them to generate saturated flow. So they are not really supposed to generate saturated or drainage flow to measure the salinity in that. So calculating the leaching requirement under a very efficient irrigation systems, that really is difficult. So what we need to do is to use the salinity of the root zone instead of looking at salinity in drainage water, because in theory, we should not generate saturated flow when we work with efficient irrigations like micro or nano irrigation system. The other thing is that, do we need the leaching to start with? A lot of people, they add the leaching requirement with every irrigation. That's wrong, because you only need leaching when the salinity reach to a level that harms the plant or the crop. That's one thing I learned from specialists in plant physiology. The other thing is that, do we use saline water to leach? It means that if you are using saline water for irrigation, you add 10% of that water, you are also adding 10% extra salt. So that's not a good idea. So to leach, it means that you have to use a water with less salt level compared to the usual irrigation water in order really to leach. You cannot leach with the same salinity. So that's one important issue really I should raise, that one is that you don't need to leach every irrigation. Two, only you leach when the salinity level becomes harmful. Three is that when you leach, you use water with less salinity than the irrigation water. The other thing is that also I would encourage.
Dr. Ragab, please. I think we can give the floor to Professor Kang, and then we can come back to you.
Yeah, just one second. The last thing for Dr. Khan, we developed salt-med model, and it is available on ICID website. And he has got really a good data set that his students could use that model to run it with what-if scenarios using the data of the 20 years that he presented. I'm quite happy to help. Thank you.
Thank you, Dr. Ragab. You raised very important points, and I can give the floor for Dr. Khan to. Yes, Dr. Khan.
Hey. Okay. So it's there are many good comments, and I think some comments, question I may answer after this meeting, because I'm not catch the meaning of the each question is very clearly. This is so about the unit of water use efficiency. So this is usually, and when we publish paper, you know, in the in crop science or some in other fields, usually use this unit. So it's angry the unit of definition and for ICID. So I think the next time, and when I submit, when I publish paper, and when I give the report, so I think I should, according to the standard definition of ICID. Thank you. Give me good suggestion.
Is that Okay, Dr. Kang,
Okay.
would you like to add another? I think, Dr. Felix, you mentioned also some important points, and also some points raised by Dr. Ragab, but later on we can collect all the points and will prepare the answer with Dr. Kang to all. And as you know, for us as ICID, now we have started a series of webinars about the technology in different schools. 2 months ago, we had with us experience from Australia, and we are trying to reach to simple and easy tools. It could be used by the small farmers. We need to have a language between the farmers and the soil, crop, and situation, because the farmers they cannot use numbers, but we can give them like colors, and based on this color they can take the right decision to irrigate, and how we and when they can stop, how they can monitor the soil and so on. And Dr. Ragab also raised the of the salinity of irrigation water, because as he mentioned, if the water for micro-irrigation is saline, we have to consider how much salinity we are adding to the soil. And I think for salinity management, it needs a more discussion, and it depends, of course, as Dr. Eben mentioned, it depends on the rain, if there is rain or not. So based on the situation, we can select the right way we can manage salinity. And by this, I think we can give the floor now for Dr. Varma to see the questions raised by the participant.
Okay, thank you, Dr. Wawa. Professor Kang, I think you can see the question answer box where number of questions are there. So we can take a few questions out of there, and then few persons have also raised a hand. So if time permits, then we can give time to them. We'll take the questions only for 20 minutes, because by that time it will be 2 hours.
Please, Dr. Varma, could you please read the questions?
I am reading. Dr. Rohit Lal from India, he has raised 2 questions basically for Professor Kang. It is, how do we maintain 20 centimeter depth of the drip emitter in case of intercropping cultivation practices? And second is, which soil type this is suitable?
Please, Dr. Kang, is that clear?
Yeah, I didn't catch the meaning clearly. Can you explain to me, Dr. Waba?
Yes, the question is how we can use the 20 centimeter for to control the soil moisture with different crop at the same time. If you have intercrops together, how you can adjust it at and monitor at 20 centimeter. Is that right?
Yeah.
Yeah, that's a good question. Yeah, if there is the interplant or something, that is, I think, so maybe in the future we can do such research work. But usually, you know, for micro-irrigation, when we design the system, we should consider the crop types. So for each type of crops, because the water consumption are different, so we make the unit of the control unit of micro-irrigation, and we should consider this condition, make the, you know, the different, the submit and the unit. So in this case, we can set the tensimeter for each type of the crop. Yeah. So this is also in our practice, and So we usually for each, actually there are many conditions we should consider. For example, soil types maybe the change and in the field, and also different crops. Also, the slope, the upper slope, down slope are also different. So this for this conditions we should consider, and in designing our micro-irrigation systems, and then makes the water management and depend on the different conditions. Okay, this.
Okay, Professor Khan. Another question is from Mr. Muhammad Bijan Khan. He wants to know how could you convince the farmers to implement your different irrigation systems, and what are the social difficulties?
Is that clear, Professor Kang?
Yeah, please explain to me again. Thank you.
Mr. Muhammad is asking, how could you convince the farmers to implement your different irrigation systems, and then what are the social difficulties associated with that if you have to convince the farmer?
Allow me, Professor Kang, to answer these questions.
Yeah, please explain again.
I think the best way to convince the farmer to have pilot farm, and you can collect all the stakeholder farmers from day one to see by their eyes, and once to see the result by themselves, if they can see it is effective, cost effective, and at the end, after to see by their eye, I think they can, no need to convince them. After that, they can take the decision to apply the new technology. If we have any new technology, we must have a pilot farm or demonstration farm, and to share with them all the idea from the beginning, and at the end, if they can see a good result for them, no need to convince them. They will take the decision to apply it.
Thank you, Dr.
Yes. Yes, and yeah, it's 15 years ago, I was invited by the 3 government, from different provinces, and at that time, and we together to do the work. So how to make our technology can be accepted by the farmer. So we together, we first we set the demonstration area, and then they make the farmer themselves themselves and to read the water meter, and to read the the electric meter, and to win the and to observe the yield or something. And then in my slides, and that is the results, that is good obtained by farmer, not by me. So in that case, when other farmers go to their field, so that farmers tell them, you see this, this is observed by myself. So other farmers, they believe, oh, that is true. Yeah, it's we did many, we did many demonstration works with the local government and for demonstration, and also this spent many my time to do this work.
Thank you, Dr. Khan. Another question is from Professor Dr. Ahmed Qadri Behlol from Egypt. So he is saying Egypt has a major national initiative to transfer flood irrigation to modernized irrigation techniques in the old land in the delta of River Nile to mitigate water scarcity. What are the possible impacts on salinity of the old land and crop yield? What are the important recommendations to the farmers in the old land? These are the two questions he has raised regarding transfer from flood irrigation to modernized irrigation system in Egypt delta of Nile. The question related with the impact on salinity and cropping, and then what can be the recommendation to the farmers.
I might answer this question based on our experience in Egypt. Agriculture drainage is very important for the long term for sustainability, and based on our condition, it is a must to keep our drainage system working together even with micro-irrigation, because we had some experience for the new reclaimed area. Some of them, they already long time ago, before reclamation, they have a recommendation for international consultant that there is no need for drainage system because the soil is sandy soil, and with this kind of accurate and micro irrigation system, no need for drainage. But after short time, there was a collapse, some change in the soil, and at that moment they come to us and ask, please, we need to have a solution for these problems. So at that time, the solution was to install a drainage system to remove the soil and the water logging and so on. So our main recommendation for our condition, the drainage system is very important and is a must for our condition. And in fact, in Egypt, we have to consider, we have one of the best and the biggest drainage project in all the world. And I see this kind of project, it is one important key for sustain our soil and the crop, and it is careful of. Is there any other question, Dr. Barma? Yes, Dr. Bartali, maybe he has a question. Dr. Bartali, please. Dr. Bartali from Moroccan National Committee. You are welcome, Dr. Bartali. Please.
Hello, do you hear me?
Yes.
Thank you
Yes,
so
please.
much. Thank you so much, Dr. Weba. Thank you also to ICID, and thank you for the presenters, Dr. Kang, and the comments of Dr. Kristen and Faisal. I would like to ask two questions, if possible. Given the importance of the development of micro-irrigation in China, it's about 10% of the total irrigated area, which then comes to 7 million hectares. Dr. Kang, what are the levers used to promote and enhance accessibility of small farmers to micro-irrigation in China? And my second question is to Dr. Kristen. In Australia, for the example of Australia, what are the other environmental impact of micro-irrigation and solutions to cope with that? Thank you. In the meantime, I would like to please, excuse me, to mention that in 5 months from now, the ICID will be holding its 10th International Micro-Irrigation Conference in Morocco. It's from 25 to 27 January 2023. It's going to be the first time it's held in Africa. And you know the effort that has to be done in Africa. So we look forward to benefit from my lessons to ensure sustainability of micro-irrigation projects. Thank you.
Thank you, Dr. Bartali. Dr. Can you answer the first question? No, unmute yourself. Dr. Kang, please unmute yourself. Yes.
Okay, Dr. Baba, please help me to explain the question and let me make it is question more clear. Please, would you help me to explain the first question?
I think the question around, please, Dr. Bartali, the first
Yes.
question.
The question was, what are the actions used to promote and enhance accessibility of small farms to micro-irrigation technologies in China?
Yeah, this is a good question. Actually, you know, and for micro irrigation and sprinkler irrigation, and usually if the farmers have the larger area of the farmland, so it's easy to be and accepted to use. But for the farmers that have the farmland in very smaller size, so in this case, and you know, usually depending on the what type of the crops, and if the cash groups, so for example, if the greenhouse or something, so it's a little easy and to promote. But if the some, you know, the crops with low economic values, so in that case, that is difficult, you know, because of what? Because, you know, nowadays in China, and for farmers' family, and there's income from agriculture, and the rate of the it's decreasing gradually. So in this case, and for the, you know, the farmers with smaller size of fields, so usually and they still and they use the traditional method. For example, this is in China, you know, in north of China plain, and usually and the farmers like to use the, you know, the water transport by the pipeline, and then to the field, then they met the field scale is makes the uniformity increased, and then they use this system is much more. So it's also, you know, and we also and with the local government made some of the demonstration and to make the farmer they can accept our technology. So and still, you know, if the for the smaller size, very smaller size field, such farmers and still is very difficult.
I think for small farmers, Dr. Kang, it need kind of consolidation, maybe just to collect the small farmers together to apply this kind of technology. Dr. Eben, can you please answer the second question?
Yes, thank you very much, and thank you very much, Professor, for the question. So in Australia, micro-irrigation has largely been applied to permanent crops, so largely to fruit trees, nut trees, and grapevines. Some micro-irrigation has been used on, is used on cotton crops and processing tomato crops. So that's the context. In terms of environmental impacts, I would say they're largely positive. And if I think about the overall changes, I would highlight that where we were using flood or furrow irrigation, this was resulting in high water tables, waterlogging, not everywhere, but in, you know, in general a risk was high water tables, waterlogging. Now switching to micro irrigation has much reduced those risks. So water tables have dropped, waterlogging is less prevalent, and because of those two, salinity issues have abated. So where we had quite quite serious salinity issues either existing or developing, the switch to micro-irrigation was able to control that issue of buildup of salinity and reverse that buildup of salinity. So those, I would say, they're very largely positive. The only negative, but it's not necessarily totally unexpected, if you might say, result of large-scale adoption of micro-irrigation, and not just micro-irrigation, but more efficient irrigation, has been on the subject of return flows. So what I'm talking about here is the excess water from one irrigation farm that would then go to the drainage system, that would then be either used by farmers downstream or returned to a river, and that water be used downstream. So as irrigation farmers have become more and more efficient at applying and using water on their farms, and also collecting and using rainfall on their farms, that means that there's been less return flows to the drainage systems and to the river systems, which means then there's less water available to downstream users. So there is this important point when we talk about water use efficiency and micro-irrigation, making more water available and so on, is to think carefully about the scale of the water balance that we're talking about, and to understand how the water balance works at the moment and where water flows to from farms, and then assess what the changes will be as we move to more efficient irrigation and what those impacts may be downstream. So that's just a broader context and a broader issue that certainly caught Australian water planners, water managers by surprise, and then had to be dealt with to continue to supply water to downstream users who previously relied on those return flows. So yeah, I hope that helps shed some light on the Australian situation. Thank you.
Thank you, Dr. Ibn. Dr. Verma, I wonder how much time still for us?
No, actually time, we are already covered 2 hours, but Dr. Faisal has raised a hand. He wants to say something.
Yes.
So Dr. Faisal, you can speak. Unmute yourself. Yeah.
Yeah, thank you very much. I'm sorry, if you allow me just a small comment, because it's very important what asked Dr. Al-Hussein. I would like to add that China is a very good example how micro-irrigation is developed in this country. Just to remind you that during the 80s, after water and food shortage assessment, the Chinese government declared drip irrigation technology to be amongst the top priorities for development. And this is very important. If you have the political commitment, after that, everything will follow, and you will develop and increase the use of this kind of technology, etc. So the policy level is very important for all the countries where they are they want to develop this micro-irrigation technology. Thank you. Over to you.
Thank you, Dr. Faisal. Is there any other question?
There are a number of questions, 4 or 5 questions from Mr. Dilip Yevlekar and from others. So what we can do, we can request these attendees or participants to directly write to Professor Khan with a copy to us, and then Dr. Ivan and then Dr. Faisal, then they can reply it. Or we'll share these questions with the panelists and the speaker, and then these questions can be replied directly. Because now it's already 2 hours, more than 2 hours the webinar is going on. So because of the engagement, and then sorry for the persons who have raised their hand, we cannot take their questions or suggestions. So because of the time constraint, and these questions we'll share with whatever questions we are having, we'll share with the speakers and panelists, and then they will provide the answer directly to them.
Okay, thank you, Dr. Verma.
And Dr. Baba, one more thing. Some
Yes.
of the participants are asking for the presentation. If Professor Kang is agreeable, then he can share the presentation with us, and then we'll upload that presentation in PDF form in on our website along with the recording.
So, Professor Kang, we are please after the webinar, you can share your presentation, and then we can share it with the participants in PDF. Okay?
Yeah. Okay. Yeah.
Okay.
I can.
So, thank you very much. Before to conclude, Dr. Ragab would like to have something to add.
Just to thank really Professor Kang and the panel members, Dr. Evan Christian and Dr. Fasser Chini, for their valuable remarks and comments. I would like to thank also Dr. Bartali for bringing up the forthcoming workshop or conference on micro-irrigation in Ad-Dakhla, Morocco, which I also support the participants now to take advantage of this conference in January next year, because it will be with more speakers as well. So you will have more variety of topics, and it will enrich our knowledge more further. So I would like to thank you, Dr. Wahba, for organizing such a good and fruitful seminar with a number of participants, over 300, which is really quite remarkable. That's thanks to your help with the ICID activities. Thank you all, and have a good day.
Thank you, Dr. Ragab. Dr. Kang would like to add something.
Okay. Today, and yeah, there are many good comments and questions. So, Dr. Waba, please and connected it, and then sent me by email, and I will answer all the comments and questions and after this meeting. Okay, sure. So thank you. Thank you much for and President Nagabi, Felix, and Dr. Waba, and also, the Wama and from headquarters of ICID office, and the Evan and the face, the face and everybody. And thank you very much. And so this is quite a good chance for me, and to share our research and to discuss, to exchange with you. And thank you.
Thank you very much, Professor Kang. Dr. Evan would like to add something. Dr. Faisal?
Just to thank all of you, and I was really pleased and honored to take part of this webinar. I look forward to participating in other ones, and I encourage ICID to continue in this way.
Thank you very much, Dr. Faisal. Before to conclude, I would like also to add what Professor Bertali mentioned about the 10th International Micro-irrigation Conference, Morocco, between 27 to 27 January 2023. The most important here, there is a call for papers, and I would like also to encourage to have more papers, because a special issue of World Water Policy Journal will include the best paper presented. So you are most welcome to submit the paper as soon as possible for this important event. At the end, today we have learned more during the presentation and the fruitful discussion. And at the end, I would like to thank and give hands to the distinguished speakers, Dr. Kang, Dr. Eben, and Dr. Faisal. We have enjoyed the presentation and discussion, and we learned too much, as I mentioned. I would like to thank all the participants for their time given to attend this important event and the valuable discussion. I wish you all the best of everything and looking forward for your kind contribution in our future event. And thank you very much.
Well, Dr. Baba, first of all, I thank Professor Kang and Dr. Ivan and then Dr. Faisal for giving this wonderful webinar and enriching our knowledge. I thank Dr. Raghav, our president, who agreed to attend and then share his views and experience. I thank all the participants who have attended in a large number, and still we are having more than 250 participants at the moment. And then I thank Dr. Baba, because he, as a moderator, he has moderated this webinar very well. And then it is his initiative to have this webinar. And he has already taken the initiative to talk to Professor Kang to agree for this webinar, and Dr. Faisal and Dr. Ivan to come as a panelist. So I thank Dr. Baba, and I thank one and all for making this webinar very successful. Thank you. Thank you very much.
Thank you very much, Dr. Varma. Thank you all. Thank you.
Thank you.
Thank you.
Bye-bye.
Bye.
Bye, everybody.
Bye-bye.
Bye-bye.
Bye-bye. Thank you. Thank you.